Georgina, thank you ever so much for having us here today. Thinking about the web and Tim Berners-Lee's invention, what was the problem he was setting out to solve when he came up with the web?
Right, so in I think about 1989, Tim Berners-Lee was working at CERN, and there was a database of research and research papers that he wanted to make more accessible. He wanted anyone, anywhere in the network to be able to access media and research and stuff like that. Yeah.
Was the web's invention something that was inevitable? Would there have been other clever solutions to the same problem?
Probably, yes. Maybe the web wouldn't have always come out the way it did, but I suspect that, yeah. And there were other alternatives that were being worked on at the same time. The web became fairly popular, and it allows, I think because it's so extensible, it let people build on top of it. Yeah.
The fact that CERN gave it to the world for free, relinquished all sort of intellectual property rights on it, would have helped?
Yes. So I think about the same time that CERN said that the web would always be free, Gopher, which is one of the other alternatives, said that Gopher would no longer be free.
How does it actually work?
So the web is often confused with the internet. The internet is the connection of networks that makes the World Wide Web possible.
Right, and that dates back an awful lot further.
Yes,
yeah.
Yes. But the web is the connection of web pages and content that's linked together in the World Wide Web. So I guess what technologies make it possible?
Yeah.
So the main one would be HTTP. So
which stands for
Hypertext Transfer Protocol, I think. Yep, Hypertext Transfer Protocol. So this is HTTP is the language that browsers and servers use to talk to each other.
Okay.
When you want to fetch a request from a server, your browser sends a request in HTTP and it gets back a response in HTTP as well.
But this is different from HTML.
Yes. So HTML is the markup language that's used to describe how the website, how the page that you're looking at looks.
Okay.
HTTP, the protocol, can be used to transfer data in many different kinds of formats. It can be used to transfer HTML or images or videos, etc. Yeah.
So I type something into the little address bar up at the top of my browser. What happens there?
There's a whole bunch of different scales that we could talk about this, and this is actually something that I think I could talk about on a whiteboard. So the first thing that will happen, so you type in a request in your browser. Did you type in the URL, or did
I would
you
have typed in http://www.google.com or something
Okay,
similar.
so you gave your browser a URL and you said, go find that website.
Yeah.
So the first thing your browser needs to do is it needs to do a DNS lookup to find what server should respond to that.
Right. And DNS is?
DNS is the domain name system that hosts and servers and computers on the internet use to transfer between the domain names that are very easy for people to remember.
Such as www.google.com.
Yep, yeah. And the IP addresses that are very easy for, that computers use.
Okay,
yes.
Right.
Yeah. So
this is the sort of 4 numbers with dots in between them? Or
yes, 4 numbers if it's
these days,
IPv4
yeah.
and yes, IPv6, whole different issue. Very similar. So the first thing that happens is your computer does the DNS lookup. It goes from www.google.com to an IP address, 74.125.5.11.
Very impressive.
Not really. And then your computer will make a request to that server. That request is made over HTTP, and the server sends back a response.
Right.
Yep.
What's the response look like?
So the response is in text. So the response is in HTML.
Yeah.
You can view the raw HTML. So if you ever right-click on a page and then say View Page Source, you can see the raw response. If you do that for something like google.com, it's probably not going to look very interesting because it's been compressed and obfuscated.
Which is very kind of you.
Yeah, well, we're saving all of your bytes.
Thank you.
But if you try that for some other web pages, you can start to get an idea of how this works.
And sometimes we get back other responses from the web server. I see 404 and 403 and other numbers getting displayed.
Yeah. So when the web server responds, it sends you the response over HTTP. That response comes with a status code.
Okay.
And generally, 200 is success, okay.
Here's a page.
Yep, here's a page. 302 is this page is moved, go somewhere else. 404 would be not found or, it's not there. 403, unauthorized. 418, I'm a teapot. Okay, well, that's technically not a HTTP status code. That's a different protocol. But, right. 500 would be a server error and stuff like that. Yeah. So this is a shorthand to allow the browsers and the servers to communicate.
And this is part of the protocol as well.
Yes.
Yeah.
Okay. But that's separate to the HTML page.
Right. Okay, with you. I suppose one of the other technologies must be the URL, this way of specifying pages. How do they work?
So the URL is the Uniform Resource Locator, and it specifies where you should look for a particular resource. The resource in this case is a web page or various things.
I said earlier I type in HTTP. I guess I should be typing in HTTPS. These are different things?
So HTTPS, so the S stands for secure.
Right.
Some websites will actually redirect you to the secure version. So, for example, if you try and go to http://google.com, it will send you to HTTPS. But generally, you should prefer the secure connection. The secure connection does two things. So, when you use HTTPS, your browser will check that the website that you're going to really is the website that it claims to be.
That's important.
And then the other thing it will do is it will encrypt the connection between you and the web server. Yes.
And how secure is HTTPS?
That's a very, very, very complicated question.
Okay. Is it something?
Or it's a simple question with a very complicated answer, maybe. But sorry.
Can we trust this?
So you can trust HTTPS if you trust your browser, if you trust that your browser's implementation is correct, and if you trust the authority that signed the certificate. So HTTPS requires. HTTPS relies on certificates signed by a certificate authority, and the certificate is owned by the owner of the website. And when you try and go to that website or that domain, your browser requests a certificate, the web server sends you a certificate, and you can verify that certificate proves that they are who they say they are.
Right.
It's very complicated. Yeah.
And so if I connect via some public Wi-Fi network on a train or something,
you should use HTTPS.
I sometimes get warning messages come up saying, this isn't the site that you're thinking.
Yes.
You think it is because it's the login page for the Wi-Fi provider, for instance.
So unfortunately, the internet and the World Wide Web were designed in an era where we could trust each other.
Okay.
Very different to how it is today.
Which you could do if you were working at CERN or
you could trust that
4 of the US military.
Exactly. You could if you were Tim Berners-Lee working at CERN in 1990, you could trust that your colleagues weren't going to try and put up a fake website to pretend to be your bank.
Yes, quite.
But it turns out
about that.
We can't make those assumptions anymore. Yeah. So I guess I don't know. It's kind of like a tower of blocks, right? And every time we add a spectacular new technology that lets us do internet banking or something, we have to sort of build it up into a more precarious tower.
But the technology on which HTTPS rests, the signing pages and the encrypting the pages as they're moving, or the content of the pages that's moving across the internet, that all that encryption technology is all out in the public domain. People know how this sort of thing works.
Yes.
And yet it's still secure.
Good security should never rely on obfuscation.
Yes.
You should never rely on the fact that your encryption algorithm is not known in order to trust your encryption. So I think this is called Kirchhoff's principle, although there's also Kirchhoff and the other Kirchhoff. So anyway, security should
There's
never...
a principle.
There's a principle. So... yes, the algorithms that are used for signing these certificates and for encrypting the connection between your mobile phone and Google are all known. But the secret key that is used to sign the certificate is not known. Those are kept very, very secret. Yes.
These technologies are so much part of young people's lives, part of teachers' lives. Is this something that ought to be taught in schools? Should young people know how to write a web page in HTML? Should they know about other things like CSS and JavaScript and things?
That's tricky because on the one hand we have it's tricky because on the one hand we have so many tools that mean that we don't have to.
Yeah.
Right. So 15 years ago, if you wanted to put a web page on the internet, you needed to know about HTML. You probably need to also know how to run your own server. These days, there are so many tools that will let you, edit wikis, for example. You can contribute to Wikipedia without knowing anything about HTML, even though Wikipedia is displayed in HTML. But that doesn't mean that it's not useful to understand how these things work. And it also gives you a lot of power to be able to create these things.
Right.
So to me, programming is like magic. It's one of the few, so working as a software engineer is one of the few, how to say, I guess programming lets you create things using only your computer. You don't need other resources. You don't need bricks to build a web page. You don't need cement. You don't need paint. So you can, when
the opportunity to make something is really limited by your knowledge there rather than access to physical resources.
When I do some tutoring at the National Computer Science School in Australia, it's a 2-week summer school where high school students come in and we teach them Python programming and HTML and CSS and JavaScript, and they use all of those things together to create. They make a little social network in groups. So there's each project group designs. Generally there'll be some theme, like it'll be about creating stories or sharing music or meetup groups or something like that. And although we think so that the most important outcome for us as the tutors is that the students learn to program. They learn to program in Python and JavaScript. And these are general purpose programming languages that you can use to do pretty much anything as long as you have the interpreter. We also make sure that they learn HTML, CSS, and JavaScript, and that they code the pages themselves.
So do you think the web is going to be with us for a long time? Is there a successor? What will be the next big thing?
I think that the web is so incredibly useful now that we're going to keep finding ways to make it more useful.
Yeah.
If you compare the web of 1990 to the web of 2016, it's already very, very different and is working in very different ways, which is a lot of, that's created a lot of challenges in order to, we're trying to make the web and the internet work for things that it was never intended to do, which creates a lot of interesting technical challenges.
So obviously your work here at Google is drawing on these technologies on the web. Can you give us some examples of how your work relates to what we've been talking about?
So my role is a site reliability engineer. At Google we have different kinds of software engineers. So we have software engineers that build things, they work on products. A software engineer might work on the Drive app for Android. write the code that makes that work, or they might work on part of Google search where they work on part of the indexing pipeline. We also have site reliability engineers, so this is my role. Site reliability engineers are responsible for making sure that the site is reliable.
Okay.
And they could be, and we call them SREs. So an SRE could be attached to, or sorry, responsible for a particular product. So they could be the SRE for Google Maps, for example. So the SRE team for Google Maps is responsible for making sure that Google Maps is always available. Always
This is important
available.
work. We appreciate this.
Right, thank you. It's a role that didn't really exist before companies like Google. So, because we work with such very large distributed systems, there's a lot that we have to do to make sure that it's reliable. At Google, we assume that everything can fail, that the hard disk can fail, the power can fail, the person can fail, that all of these things can happen, and then the system will keep running. And so that's what the SREs do. They somehow, the SRE team that I work with specifically are responsible for keeping the traffic between the user and the Google front ends reliable. So anything between you and a data center, we want to make sure is.
But that's using networks which aren't provided by Google.
Right. So that we don't really have control over. Yes.
Right.
Yeah. True. So, for example, there are when you make a request to www.google.com, there are many locations, many servers, thousands. Don't count them. There are many servers that can answer that request.
Right.
And so we have systems that will send your request to one of them.
Georgina, thank you so much for having us here this morning. It's been really interesting hearing your perspective on all of these amazing things. Thank you.
Thank you.